All right, today we are going to start with 3-4, day 1. We're going to focus on what's called the recursive rule. And so the first thing I'd like you to do is do this warm up here, and then you can hear me go through it. So hopefully we were seeing the pattern of this increasing by 4 every time, and that stayed true through all of it. So we would have 29, 33, and then 37. Letter B, this time it was decreasing every time by 2, so we'd have -8, -10, -12. Next one was a little tricky because they had one part missing in the middle of it, so you had to focus on these, which are going up by 16. So we would add 16 here and get 32. And the last one, again, a little tricky, but we should have ended up with 6 and 12 because you would have to add 3 each time to get those numbers. For number 2, I'm assuming you probably went with putting together an equation. So it starts with 28 seats and then you add 2 per row. So we would end up adding or plugging in 24 here. And if you solved, you would get 76 seats. All right, so we're going to build off of that to talk about sequences. And first, a sequence is an ordered list of numbers that often forms a pattern. Okay, so we're forming patterns like we just did in our warm-up. Each number is a term of the sequence. In an arithmetic sequence, and this is basically adding or subtracting. Okay, so you have to be adding or subtracting here to be arithmetic. The difference between any two consecutive terms, consecutive meaning in a row, is a constant called the common difference. The common difference is going to be labeled D here. So that's basically what we were finding up here when we were adding 4, subtracting 2, adding 16, adding 3. That's all the common difference. Okay, all of these would be your D value. So we need to determine whether it's arithmetic. Well, the way that we would know is if each time you are adding something, and in this case, we are adding 2 every time. So yes, this is an arithmetic sequence because your common difference is a 2. Okay, so how are sequences related to functions? So you can think of a sequence as a function where the domain is the natural numbers and the range is the term of the sequence. Okay, so let's just focus on graphing this function first, okay? Function notation. There is no b to start with, so we would start at 0. And then our slope is 2, so up 1 over 2, up 1 over 2, and so on, okay? So we would have this line, right, that goes through these points. If we have a line, our domain is negative to positive infinity, and so would be our range, right? We're talking farthest left, farthest right, farthest down, farthest up. And this would be continuous because we are connecting the dots. Remember that it's something that we can draw without lifting up our pencil. Now, if we were to graph the sequence here, okay, sequences are graphed similarly. You think of them as points. So this is the first, second, third, fourth, and fifth term. So these are points like 1, 2, and 2, 4, and the next one would be 3, 6, and so on and so on. Okay, so that's what we're graphing. So we go to 1, 2, 2, 4, 3, 6, 4, 8, and then 5, 10. Now I don't connect the dots because these are just points. This is not a line. So my domain is different. My domain would just be the 1, 2, 3, 4, and 5. And my range would then be the actual sequence, 2, 4, 6, 8, and 10. Now this one would be discrete because it's a bunch of points, okay? It's very common for everybody to want to connect the dots because the slope is your common difference, and so it seems like it would be a line because you could connect these really nicely, but you are not going to connect those points. All right, so I would like to encourage you to pause the video and see if you can do these 3. We have to determine whether it is an arithmetic sequence, and then if it is, then we're going to find the common difference. So pause the video, try it out, and I'm going to get started going over them. For number 3, you should have came up with, yes, this is a sequence because your common difference is -4. So we would be subtracting 4 each time, which is why your common difference is -4. The next one turns out to be no, because this is going up by 1, then 2, then 3. And although there is a pattern, it's not the same difference, so it is a no. And the next one, we should have came up with yes, because each time you are going up by 0.25. So let's talk about the notation of arithmetic sequences. Okay, n is the new variable that we're going to talk about, and that's talking about the term. Okay, that's typically kind of like your x value. So what we were thinking about before is our n would be like 1, 2, 3, 4, 5 here. And our a sub n is the value of the term. So it's kind of like your y value almost. Okay, you can almost think of this as x and then this as f of x. Okay, it's kind of the same thing. It's just written a little differently. So, for example, a sub 1 in this is going to be 2 because that's our first term. A sub 2 would be our second term, which is 4. A sub 3 would be our third, which is 6, and then 8, and then 10. Okay, so it's almost like a point. 1, 2, 2, 4, 3, 6, 4, 8, 5, 10, which is what we just did before. Okay, now you can see things as like a sub n minus 1 and a sub n and a sub n plus 1. And so this is typically your first term, but you could go backwards, you could go forwards from there. Okay, so don't let that confuse you. It's just a notation of telling you where to go from your original. Okay, so for example, we're going to use the example above to fill in the blanks. So this time it's saying a sub n is 8. So that means that this would be n. So if I want a sub n minus 1, that would just be backwards 1, which would be 6. And backwards from there would be 4. And if we want to go in the other direction, where we add 1, we would be going to 10 and then to 12. Okay, so we're just doing the process of adding 2 each time for this. Same thing's going to happen on the next one. Okay, if we start with 4, if we go backwards 1, we're at 2. If we go forward, it would be 6, and then we would keep adding 2, so we'd get 8 and 10. All right, so with these, we have the definition of the recursive formula, and basically all that we need to know is this part. So with the recursive formula, you are always going to list, okay, this is the part that everyone forgets. You're always going to list what a sub 1 is, which is your first term. So it's kind of redundant. You'll just say a sub 1 is, and then you'll say a number, okay? And then the other part of it, you will always write a sub n equals a sub n minus 1, and then you're going to fill in the difference there. So the only thing that changes are these two numbers. Okay, so for example, if we wanted to write the recursive rule or the recursive formula, we would first identify what a sub 1 is. Okay, well, let's focus on the actual thing itself, which was up here. Okay, so 2, 4, 6, 8, 10. So a sub 1 was 2, because that was our very first term. And then the next part would just be a sub n equals a sub n minus 1, and then our difference. Well, our difference was adding 2. Now, yes, a sub 1 and the difference are the same here, but that's not always the case. So let's get to our first example. It says, write the recursive rule for the height above the ground for the nth step of the pyramid shown. Well, each step is 26 centimeters tall. So that means that the very first one is going to start at 26 centimeters. And because of that, the difference is also going to be 26 centimeters because each one will go up by 26 centimeters. Okay, again, that's not always the case. Your difference and your a sub 1 can be different, but it is the same again here. So we're going to use our recursive rule to find the height above the ground on the third step. So what this is saying is we start at 26 and then we add 26 again to get 52. And then we add 26 again to get 78. So the third step is going to be 78 centimeters tall. All right, so just working with these and the vocab, number 7 says, here's our sequence, which we always want to, sorry, I'm trying to zoom in. You always want to make sure that it is a arithmetic sequence, which it is. Each one, this is supposed to be, nope, we're good. Each one we're adding 3, right? So if we go through, it's always 3. Okay. Now it says identify a sub 4. That means the fourth term, which would be 1, 2, 3, 4, 11. Okay. From there, it says identify the common difference. Well, we already actually did that. The common difference was 3 because we added 3 each time. It says find the next term. So that's nice and easy. We start with our very last one, add 3 more. We would end up with 20. And then it says write the recursive rule. So remember, we have to identify a sub 1, which is 2. And then we could write a sub n equals a sub n minus 1, and then our difference. Well, we identified our difference as 3. Now it says use the recursive rule. This is a whole new problem. A sub n equals a sub n minus 1 minus 7, and a sub 1 equals 2 to find the first 5 terms of the sequence. Well, the really nice part is they already give me the first term, so I know the first term is 2. So now I just have to think what happens between this term and the next one. Well, remember, this minus 7 is your difference. So that means I'm going to subtract 7 to get my next term, which is negative 5. Subtract 7, we get negative 12. Subtract 7, negative 19. And subtract 7, negative 26.